Welcome to integrals. All right, so what is an integral? An integral is also known as an antiderivative. The purpose is to find the function of a given differential or derivative. So another way of saying that is given the known or a known rate of change dy dx, can you then find the function y? And that is what an integral does. So in the integral of x to the n power dx is equal to x to the n plus 1 over the n plus 1 plus c. And we're going to see how that mechanical format works in the following examples. So we're giving an example number 1. We're given a question that says, hey, let's find the integral of x raised to the 7 dx. And you can think of that originally it was dy dx equaled x raised to the 7th power. And all they've done is move the dx over to the other side of the equation. And so you've got a dy on the other side, and then they replace the dy with the integral sign, and what they're saying is find the integral or the original function of dy dx equaling x raised to the 7th power. So again, we're going to look at our integral format, and we're going to say, okay, the integral of x raised to the n power dx equals x raised to the n plus 1 over n plus 1 plus c. So remember when we took the derivative of an equation that didn't have a variable x in it? It was a whole number with no x attached to it, and that number disappeared. Well, that is what the c represents. It represents the number that may have disappeared when we took the derivative of the original function. But in order to take the integral of x raised to the 7th power, we're going to then say, okay, well, the x is the x, and the power n is 7. So 7 plus 1 over 7 plus 1 plus c. That gives us x raised to the 8th power over 8 plus c. So the integral of x raised to the 7th dx is equal to x raised to the 8th power over 8 plus c, which represents the original function. So now we've got an integral of 4 dx. So when we take the integral of that, we've got 4 x raised to the 0 plus 1 over 0 plus 1 plus c, giving us a function of 4x plus c. And if you think about that, if you took the derivative of 4x, it would give you a dy dx equal to 4. So you can see that this is the antiderivative of derivatives. So integrals are antiderivatives. It's just that the plus c we don't know because it's already in dy dx. So we can't get back to the original plus c if there was a c. So here's the example 3, the integral of 5x squared minus 12x plus 8, all that to dx. And because they're all individual terms, we can just take the integral of each individual term. And you can see we've got 5x squared plus 1 over 2 plus 1 minus 12x raised to the 1 power plus 1 over 1 plus 1 plus 8x to the 0 plus 1 over 0 plus 1 plus c. And that all simplifies down to that bottom line. Okay, example 4. Now there's two things going on that we need to make sure we point out or that we pay attention to. Okay, so now we've got a term raised to a power. So now we're dealing with power. So we're going to have to do an extra step here that I want you to pay attention to. So first thing is just raise it, instead of get rid of the square root and just raise everything to the half power. Now, you see that fourth bullet line down where we've got 6, or the third one, now we've got our 6x plus 2 raised to the half power. So the trick is, once we get to this stage, we want to take the derivative of the inside of the parentheses, any x variable in there. So that gives us that 6. So we really want, now we're going to pull 6. What we want is another 6 outside of the parentheses. And what that's going to do is allow us to then treat the entire parenthesis like it's its own x. So, but the problem is once we've got a 6 here, we need to times because we're adding in the extra 6, we need to multiply the whole entire equation by the reciprocal of that number so that we balance each side of the equation out. And so that would be 1/6. And you can see in the next bullet, you can see the 1/6 is now outside of the integral symbol. And it's being multiplied by both sides of the equation. So now that we've got the 1/6 there and the 6, we can now multiply that on the right side of the equation. And we can treat the 6x plus 2 raised to the half like it's its own whole x term. And so you can see the first step is to multiply the 1/6 by the, now we've got our, go into our normal function or our mechanics that we define in the top bullet. So we've got the 6x plus 2 raised to the half plus 1, that's n plus 1, divided by n plus 1, half plus 1, plus c. And now you can see in the next one over, you've got 6x plus 2 raised to the 3/2. So we're just simplifying or doing the algebra over 3 over 2 plus c. And then the next one over, now we've simplified even more, and we've got 1/6 times 2 over 3, 2/3, times this 6x plus 2 raised to the 3 over 2 power plus c, and that all simplifies down to 6x plus 2 raised to the 3 over 2 power divided by 9 plus c. And you can see on our left side we're now returning back to our original integral equation where we've got the integral of 6x plus 2 raised to the half power is dx is equal to the quantity 6x plus 2 raised to the 3/2 power divided by 9 plus c. So there's a little bit in there. You just need to practice and understand what we're doing, and what that extra step does is allow us to treat the entire quantity as an x number. So this one is similar to the last problem. We've got a power here. So what we need to do is take the derivative of the inside, the part that's raised to the power, everything that's on the inside that's raised to the power, and that gives us that 2x. So we've got an 8x sitting there, and we really don't want the 8x. We need to get it to 2x so that we can do our integral trick on the quantity. And so we need to figure out what times 8x is going to turn that into a 2x, and that's 1/4. And so if we're going to multiply that section by 1/4, we need to multiply the entire equation by 4, the reciprocal of 1/4. And that gives us, and now we're ready to take the integral of the equation. And so now we've got the integral of that is going to be 4 times x, the quantity x squared plus 3 raised to the 3 plus 1 divided by the 3 plus 1 plus c, which all that simplifies down, and we can say the integral of 8x times the quantity of x squared plus 3 raised to the 3rd power dx equals the quantity x squared plus 3 raised to the 4th power plus c.